name is Praneet, and I'm a rising junior at Rington High. And for my final milestone, I was able to sew this ESP32 and accelerometer on my glove and also finish assembling this chassis kit and car. And I also was able to make two files, a sender file and a receiver file, which contains two distinct sets of code, one for the sender ESP32, which is on my glove, which will be on my hand essentially, and one for the ESP32 on the car, which is the receiver ESP. Now, the whole purpose of doing so was to control the car with my hand. And as I spoke in my earlier milestone videos, along with this sender ESP32, there will also be an accelerometer. This accelerometer has a built-in 3-axis gyroscope, which will be the essential module controlling the car, as it will be making sure that the car is moving in certain directions, which I want it to move in. Now, let me show you the code for the sender and receiver ESPs. So on the left here is the code for the sender ESP32. So this code will essentially be uploaded to my ESP32 on this glove right here, which will be on my arm, and this will be controlling the car. So this sender ESP32, the first thing I had to do here was to get the MAC ID of the other ESP32, the receiver ESP, which is on the car, as you can see here, and write that in this line. And this was to ensure that I was able to connect the two ESP32s. And upon doing so, inside the loop, I converted radians to degrees. I spoke about this in my earlier milestone videos. However, I'll repeat that. So radians was the default measurement of the gyroscope, and I preferred degrees as I found it easier to work with. So I converted radians to degrees here. Afterwards, I basically made a move forwards, backwards, left and right code, and I put that as if, else if, else if, else if, and else. So if the serial monitor reads degrees between this range, then it will move forward. Otherwise, if it reads anything between this range, then it will move backwards. And the same concept applies to left, right, and stop. Stop is when none of these ranges are read. And again, I have uploaded this to my sender ESP32, and this code has been stored there. Moving on to my receiver code. As I spoke in my earlier milestone videos, I made two motor codes, so motor A and motor B. And the reason for this is since there are two sides on my car, side A and side B, I'm controlling the entire car by two sides. So motor A would mean side A and motor B would mean side B. So this is the reason why I made two motors here. And motor A, essentially motor 1 pin 1, motor 1 pin to enable 1 pin. This is all the GPIO pins that are corresponding with my motor driver. For example, on my motor driver, you cannot see it right now, but it's inside the car. It has ports for two motors. So that is one motor 1 pin, another motor 1 pin, and an enable A pin. So all those three pins correspond with one motor, which I declared here as motor A, and all the other pins, motor 2 pin 1, motor 2 pin 2, and enable 2 pin or enable B pin, are corresponding to the other motor, motor B. Upon doing so, I applied the same concept I did in my sender ESP32, which was to exchange MAC IDs. So for the MAC ID on my receiver, I basically got the MAC ID of my sender ESP32, which was on my hand, and plugged that into this line right over here. Upon doing so inside my loop, I basically made this code where if the message sent was forward, then the outcome would sort of be this. So low basically means like low speed or reverse, and high basically means forwards. So motor 1 pin 1 is connected to one specific side, motor 1 pin 2 is also connected to that same specific side. Now motor 2 pin 1 and motor 2 pin 2 are on the opposite side. So low low and high high right here would basically mean that the two wheels that are parallel to each other on the opposite sides would basically move at the same rate, or basically react the same way, whereas the two other motors that are parallel to each other will move in the same way. And the speed of this would be 220 RPM, as you can see over here. And moving back to this line right here, the reason why I did not spell out forwards or forward completely, as I'm doing here in my serial.println line, is because this library had a bug which would not read the last letter. Therefore, I did not include it. And you can see this in all of my other segments as well. For example, backward, left, right, and stop. And again, the same concept of this I applied to moving backwards, left, right, stop. So if you see my motor 1 pin 1 and motor 1 pin 2 are low and high, I basically reverse them here. So motor 1 pin 1 is high, motor 1 pin 2 is low. And again, that same concept applies here for moving left and right. And stopping would basically mean none of the wheels are moving or all of them are low. And if none of this happens, then there will be a message that will read as error. And this will tell me that there is a problem. So this was a quick video on my final milestone. I had a lot of fun making this project, and I'm very excited to add modifications like an ultrasonic sensor here and here so that it can detect obstacles, and potentially also add a camera. Thank you very much for tuning in today.